The most powerful software ever built writes essays, code, and poetry, yet it has never understood a single word it has ever said. Because underneath, the smartest program on Earth is doing something almost embarrassingly simple, over and over, billions of times a second. To see how, forget everything you have heard about artificial intelligence. There are no rules inside, no dictionary, no grammar book, nothing. What sits inside instead is a vast web of numbers, billions of tiny dials, each one nudged by what it has read. In 2026, these webs range from 7 billion dials in small open models to over 1 trillion in the largest one. 1 trillion adjustable numbers, tuned by example, with no human ever writing a single rule about what any word means. And every one of those numbers exists to serve a single task, the task the whole machine is secretly built around. But before it can perform that task, it has to do something strange to your sentence. It has to break it apart. The task itself is this: predict the next word, feed it text, and it answers with the most likely piece to follow. Essays, answers, code, all of it is that one guess, made again and again, each new word built on the last. So how does a machine that only knows numbers read your words at all? It never sees words the way you do. First, it chops your sentence into tokens, small pieces, a whole word, part of a word, or a single mark. The word unbelievable might split into 3 tokens. A comma is its own token. Every piece gets a number, its own identity. Now your sentence is a list of numbers. And numbers are the only thing this machine has ever actually been able to handle. But a bare number means nothing. Cat as token 429 tells the model nothing about fur, or whiskers, or being alive. So each token becomes a long list of numbers, a coordinate, placing that word somewhere in a vast, invisible space of meaning. In that space, king and queen sit close. Cat and dog cluster. Meaning becomes distance, and distance is just arithmetic. This number trick worked beautifully, until the sentences got long. And when they got long, the early machines fell apart. To understand why, you have to see how the first language models read, painfully, one single word at a time. Imagine reading a novel through a keyhole, allowed to see only one word, forced to forget almost everything that came before. That was the old design, the recurrent network. It walked through a sentence step by step, passing a small summary forward. Word by word, it updated that summary and moved on, never seeing the whole sentence at once, only its own fading notes. For short phrases, this was fine. The model held enough to guess what came next, and the notes stayed fresh. But across long sentences, the early words simply faded. By the end, the model had forgotten how the thought began. Ask it about something 20 words back and the memory was gone, blurred into a summary, too small to hold it. Worse, it was slow. Each word had to wait for the one before it, so the reading could never be sped up. You could not hand the whole sentence to 1,000 processors at once. The design forced everything into a single file line. For years, this felt like a wall. Then in 2017, one idea knocked it down in a single stroke. The idea was almost insulting in its simplicity, and it had been hiding in plain sight the entire time. What if a word did not have to wait its turn? What if every word could look at every other word at once? That idea has a name. It is called attention, and it is the engine inside every large language model today. In 2017, a paper titled "Attention is All You Need" introduced the transformer, and the whole field changed overnight. Attention throws away the single file line. It reads the entire sentence at once, every token present, all at the same instant. Then each token looks at every other token and asks a simple question. Which of you actually matters to me right now? Take the animal did not cross the street because it was tired. What does it mean, the animal or the street? Attention lets it reach back, weigh both, and lock onto animal, because tired belongs to the animal, not the road. Every token does this with every other token, scoring how strongly each one pulls on the rest, all in parallel. This solved the memory and the speed at once. But attention alone is still useless until the model has seen enough. A newborn transformer with perfect attention knows nothing. Its billion dials start as noise, meaningless, random, blank. Something has to tune those dials until noise becomes language, and that something is the most expensive part of the whole story. Training is deceptively simple to describe. You show the model text with the next word hidden and ask it to get. It guesses, you reveal the real word, and you measure how wrong it was. Then you nudge every dial slightly toward right. One guess changes almost nothing, but do it across hundreds of billions to trillions of tokens, and the dials slowly find order. That is enough. Trillions of words, most of the public internet, books and code, read once to learn what follows what. Nobody labels this data. Nobody writes rules. The only teacher is the next word itself, hidden, then revealed, billions of times over. And from that single game, something strange emerges. Grammar, facts, reasoning, style, none of it programmed, all of it inferred. The model was never told what a verb is. It simply saw enough sentences that the pattern of verbs became unavoidable. Yet when the finished model finally writes for you, it does it the way you do one thing at a family dinner. It does not pour out a finished answer all at once, fully formed, the way it read the sentence you gave it. One token, then stops. And there is a reason this same machine can suddenly remember an entire book. This is inference, the moment it answers you. It predicts one token, adds it to the sentence, and reads the whole thing again. Then it predicts the next token, and the next, like passing a story around a table, each person adding one word. That is why it seems to type in real time. You are watching it guess, commit, and reconsider, one small piece at a time. Every word you have ever seen it write was chosen this way, alone, in sequence, each one shaped by all that came before. And it remembers the whole book through position math called rope, which in 2026 stretches its memory to 1 million tokens. 1 million tokens is roughly several long novels held in mind at once, the exact thing the old keyhole design could never do. So the full picture is this. Break text into tokens. Let every token attend to every other. Guess the next. Repeat. The embarrassingly simple thing from the start was true all along. The smartest software on earth is a next word guesser at scale. It does not know that grass is green. It knows that after grass is, the word green is overwhelmingly likely to come. Understanding, or a staggeringly good imitation of it. That question is where the next video begins. For now, that is how it works.